So I'm going to continue to implement the file explorer on Godot. I'm not really sure if it makes sense to. It seems very redundant to do this on this situation. So I'm not really sure if it makes sense to put the view function here directly. And that probably doesn't make sense. But this way, I think that's it also feels kind of weird. Because now that I'm thinking like probably since this is private, it's not gonna allow me to call I think from here unless I make the file system presenter as friend class maybe. And then I put the fs change tone protected. Or and I'm not really sure if it's like a problem to put this as a public function. So the other option would be to emit a signal, I think. Well, that I think that would make sense. Unless the signal comes from the presenter class, and then I put the view fs changed as the callback function, but then I think that's probably the same thing, the same issue. Just trying to get this stuff out of the way first. Just move everything to this class, like the initial stuff. Or maybe you should ask ChatGPT what it thinks. So I'm gonna try like this first, then remove from here. I'm gonna remove the function to get the file system. Yeah. You just create it to test. So I'm gonna try like this first. So the main thing that I've been thinking about is like how to approach the threads. So I've noticed that Godot has this worker thread pool here. And it seems like this is a singleton class, and they use this at some parts here. But I'm not really sure, like I was thinking about whether or not it's worth it to create another class that would work like in a similar way, because I'm not really sure how this one works. So I'm not sure if it's worth it to use this one. And I realized that they use this on the editor file system as well. And it's probably on a function that I deleted on my case there because I wasn't gonna use. But I'm not really sure if it's worth it to use this singleton here to create the tasks. Like, one of the problems that I had was like it wasn't working before because of the I had to put the flag back again, like this flag here, to put this finish scan outside because I realized based on the error later that this function I was running this function inside of the other one, and the other one's being ran from the thread. So you can't call wait to finish from the function that is being ran inside of the thread. And apparently it needs to call wait to finish in order for the signal to be emitted. Because otherwise the thread, I think the thread keeps like kind of executing, but I'm not really sure if that's the case or not. But I know that it doesn't work if you don't wait to finish before sending the signal. It might be because of the order, just the order of the. It's probably because of the order. So I guess like what happens if you don't put this wait to finish here? This is essentially like the thread is a thread class from Godot, and the wait to finish function just calls join with some extra stuff on the std thread, and they do it based on the macros. So depending on which kind of operation system you're using, it's gonna use another library to use the built-in thread that C++ has on their standard library. So it's just gonna call join on the thread, which is kind of like the endpoint. So it's like It's as if you're saying like wait to finish the work for the thread. So I think that when you don't do this before you emit the signal, then the signal is emitted before you have the files, and then even though it runs the function, it still the class still doesn't have the files, so it updates in the wrong time. So you have to wait for the thread to finish, you send, but then the problem is you can do it from inside of the function, so you need to do it externally, and I yeah, probably the easiest way to do it is through the notification process. But the annoying part about the notification process is that you need the flag. So that's the issue. And here also I had to put, I think, scanning again on the beginning of the function. One thing that I was thinking about is putting here, but then I think it defeats the point of using the thread. Because this is the other thing. I asked ChatGPT, but I couldn't get a very good answer. Like, if you put the way to finish right away, I think that defeats the point of using the thread in the first place because you're gonna block the main thread. But if you don't want to do that, I think the only way is to put a flag. But it seems kind of wrong to put the flag. So the other way that I asked is about the scope. There is something that they use on Godot that I forgot exactly what the name is, but there is I think that they have the macro on the class model. This trans safe class here. Yeah, I think that it is this. So it's a mutex lock. I think this is the pattern, which is basically a class that has the on the constructor and the destructor. We kind of like initialize. I think this is for the locks of the thread and not for the thread. But if you put this macro here instead of a function, it's gonna automatically lock the thread and then unlock. So it's like you're creating a fence on the data inside of the methods. And it's just so easy way to do this because they put the functionality on the class. So one approach would be to do the same thing for threads. So create a class that has thread scope, for example, and then you put the wait to finish function on the destructor of the class. That way you wouldn't need to use the flag. So maybe this approach is better. And I think ChatGPT recommended a hybrid approach where for some of the tasks I use this thread scope class, which would wait to finish as the threads is destroyed. So as the function, when the function stops running, it would call wait to finish, and then it would but then the problem is I have to send the signal anyway, so I would have to put the function on the callback to the class. So maybe it's not very good. So probably like living with the flag is like the best approach because I don't see another way. But it is kind of annoying. So I think I have to put here on the beginning of the function. Just delete this. I'm doing the other way of the thing because it's just easy. Yeah, so it's complaining about the private member. It was kind of pointless to create another function to make it public just to wrap the original one. So It feels kind of pointless though. Doesn't make any sense. So I think the ChatGPT response doesn't make sense in this case. It's essentially the same thing if you put another function. It's probably on the destructor. Like this warning wasn't happening before when I was calling from the view. So I think I should do with the destructor. Yeah. So I think that this is probably an indication that there's something wrong here. I'm not really sure. So I think should probably try to ask ChatGPT just say what it thinks. But like it seems that it is using. I think on situations like this, I'm not gonna be able to send a signal, obviously, because I don't think it makes sense. I would have to wait the signal to get the model directory from the other class. So I think that it would make a lot more sense to loop over the class from the front end, which is I think is the tree update tree and create tree. So I think I should focus on those classes now, which are gonna be the hardest to change, I think. I don't really know for sure what is the best way to. I'm trying to think about like an incremental way to change things, but I'm not really sure if it's gonna be possible. Because I basically need to I need to find all the places that I'm using this file system, which is essentially the other class. Then I need to remove this, and I need to make this class independent of the other one. And like the fact that it isn't, I think that indicates that it's probably not the best design. But the thing that I'm not 100% sure about is that it does make sense to get the information from the backend. Because the backend should be the more accurate information, I think. But maybe not, because actually I think yes, because the scan changes is going to be on the model, which is the backend. So it makes sense that the backend has the most accurate information and the front end is just the view. So if you are going to search for stuff, So maybe the indication is that these algorithms should be on the back end, I think. There should be a function on the back end to search for things and not the front end. I think that's what it indicates there. So every time that the front end needs to access the back end directly, either means that it shouldn't be done on the front end, which is the view, or that you should be able to do it from the tree item class, which is the class that is used to create the items on the front end, which is the visualization. So I want to see if I can think about a way to ask a GPT this. So this tree class is a class from Godot, which is the one that they use to create the tree on the front end. And like this is the roots of the tree. And then inside the create tree is gonna be tree item classes. And so the create tree function creates the tree item. So this is like it's not the root, is the class that is used to create the tree. But it's kind of like outside of the tree, I think. So there's something wrong because it's not loading. I put a print statement there to see if it is calling the function. It should be calling this function here. Remove this from here. Oh, it might be because of the root. Oh, but I don't think it's because of the root, because we should be updating the root on the other one. I think that there's something wrong with the root because of the it's not saving. I know that it saved the configuration, so it shouldn't open the state that is opening. So it's not saving the root of the. So there, I think there is a problem with the communication of the root. Oh yes, because I'm using a different one. That's why. So like the root the file. Yeah, I already know why this is happening. The one on the class I'm using to get the roots on the view is not the one that's the same that I'm using on the presenter. So I need to update the. I wonder if I can do that with the class directly just to test to see what happens. Basically this thing here. How the this is kind of annoying. I guess I can set the file system for now. So I think it's set. Yeah. If I can't do it like this, I'm just gonna put this as a public thing. So what is happening is that is not updating. I'm updating the model class when I call scan, which updates the roots of the model. But then the view is using this file system class to render stuff, and it depends on the roots of the. So it's two different models that is using. Yeah, but the problem is, I think I'm gonna have to change. Even if this works, I'm gonna have to change. It's not gonna work. I think it's not gonna work because on the create tree, like I'm passing this one, which is from the other one. So like this class is not gonna have the state. So I'm gonna have to think about this now. So how should I change this? But the challenge is figuring out a way to incrementally change, so I don't have to think about everything in the beginning and make all the changes. And maybe the root folder should probably be. Yeah, I think I should pass, but if I pass the path, it's not very good. The problem is that I don't think I'm gonna be able to get a very good answer from ChatGPT on this. So I'm gonna have to like just spend time thinking because this is something that I felt is kind of weird since the beginning, but I'm not really sure if it makes sense the way that they did it here or not. Like in my mind, it mean, but I think it's probably the only way. Like like this function is directly related is a direct reflection of the class that is created on the model, which is this one. So in the first time there, when it calls up create tree from the update tree, this one is going to be the one that is that represents the state of the root folder. And then I think that's going to recurse based on the children of this. So like the function here is that direct reflection of happens on the model, but that's the part that I'm not really sure if it makes sense to do this. Yeah, but the question, like, maybe it does make sense. Maybe it's the only way, because the other way, how else would you get? But I think that hmm, maybe it doesn't make sense because of the flow of information, I think. Because the way that they did it is just by like they hard code the path. That's the problem. So I think that's the reason why it probably feels that it doesn't make a lot of sense. Because on the original one that they have, they put the rest folder, which is the root of the project, Godot project, and then I changed to get, because I just wanted to make it work. I changed to get the model directory from the other class to work as the root. But it doesn't make a lot of sense, I think. What I could do is just create an extra layer on the presenter, but it feels kind of weird. Like I could just put the same function on the presenter that the model has, and then just like wrap the function on the model to get the roots. It doesn't feel that is the right thing to do. So I'm trying to think about like ways to ask this that I might get a useful answer. The way that I'm thinking about interacting with ChatGPT is that like you're interacting with something that predicts the collective outputs of text from human beings on the internet. So it's not really like talking to the archetypes of human consciousness, but it is kind of like because you can't really do like the one-to-one mapping because it's not really like you can't really say for sure that the prediction of the next token creates the accurate reflection of the archetypes. But I think that there is some strong correlation. So the way that I imagine is like you're talking to a ghost that is the collection of the outputs of humanity on the text that is used to train the model. So I try to think about questions, and I think that the output that you get from the large language model is going to be a direct reflection of the token space that you're interacting with. So like you have the input, which is your text, and that input is going to have like a cascading effect on the network of text, and then it is basically highlighting is a direct reflection of the output is a direct reflection of the inputs. So I usually ask myself what is most likely to have more information. But I do think that I could make a better prompts, but it doesn't matter that much. Like I don't think it matters enough to put a bunch of time into it because you're putting our power on the thing as well, which is not very good. So from like what is happening here is that this algorithm here, the way that I'm looking at it, like the algorithm here and the algorithm on the back end are basically the same. And the only thing that changes is the classes that are being used on the structure to change the data, to hold the state. And the question is whether or not that makes sense. Because if we're doing the thing 2 times, it doesn't make more sense. Is there a better way to just extract the? I think probably not. Probably. I do think that makes sense to create a presenter, but it feels kind of redundant here. So I'm not 100% sure about, because like all these functions are going to be wrappers. So it makes me think that like I think that the presenter is going to be useful for the stuff that requires multiple threads and for like synchronizing the different tasks. But then the question is it worth it? What is the best way, simplest way to connect these things? Because I want to avoid having to use the same. It feels kind of it feels kind of stupid to put on the update tree like just another function on the presenter and then call the model and then like it's kind of dumb. So the question is there a better way to do this? And since the beginning, like I didn't like that much, but it's like it's a reward. Time the ROI, return on investment on time. Not really sure if it's here because like there's a bunch of things that are connected to this stuff here. So that's the kind of the problem. It, it feels kind of that like is it might there's probably ways to simplify this because it seems like overly complicated. Like it just seems to me that you shouldn't need this other class here. There's a file list class, but I don't know for sure if that's the case or not. And if I try to change it, then I'm gonna have to think about a bunch of other stuff because this is gonna impact the other, like it's gonna impact the dialog files and everything else. So it's kind of hard to like isolate one thing at a time and then think about that. You know, this whole class here feels kind of this class here and the other thing there. I think the reason why they did it like this is so that you separate the concerns. It's easier to think about the files this way probably. It feels kind of weird. The problem is that it's kind of hard to think about like what alternative way. I think it's basically the same as this thing here. I have recursion here. That's basically what's happening. Maybe we should put the tree on the presenter. Does that make sense? I think that's probably like it doesn't make sense. Like the cache is gonna be. I think the model needs to have a cache. I found this code here for ChatGPT mentioned at least recently used cache, and then I just look for YouTube videos, and then I found this one. I think it's from Invicto or something like that. Yeah, this Ericto, however you say this. It's from Elite Code Challenge, where it basically uses a queue and a hash. So, but I'm not really sure if it's worth it to use this one. I think ChatGPT mentioned this, so I might like just copy this and then change to work with the Godot classes instead. But I think it does make sense to put some form of a cache on the model. So if the model is gonna have a cache, I think the model needs to have the tree. So and if the model needs to have the tree, the view needs to have the tree also. So am I seeing things that are not there? And maybe it is like the easiest thing to do is just to put another function there. Let me see. Last. This is another problem. Is like here the way that they're doing, they're clearing the tree. So I think that every time that there is an update, it recreates the entire state, which is not very good. But like the problem is that it might be a massive thing because it is very similar to front end. So I'm remembering about React and the fiber, whatever there. So like what's happening here is basically the same as a virtual DOM, like it's the same pattern. So you have a DOM on the front end, which would be the real DOM, and then you have a DOM on the back end, which is a virtual DOM. And then I think on React, I'm not really sure about the most recent version, but the ones that I was studying before, the way that they do it is by, so they have the use effect which allows you to do updates. And then they have the fiber, which is something like an algorithm, I think, that traverses the tree and then checks. It basically does the difference, which is diffing, the difference of the states of each node, and then it flags to see if there is any difference. And then if there is, it updates the states. And it's roughly like that, the way that the use effect works. Then you have the context, obviously, which would be like a global object that allows you to change the states from nodes that are not directly connected. And everything else is going to be a flow from the roots to the bottom of the tree through the arguments of the functions that connect the nodes. So like this allows you to update the backend without lagging the front end because you just do the work and then once everything is ready, you just swap the trees. But obviously it would be a massive amount of work to do this, I think, or to implement something like this. So obviously I want to avoid doing that as much as possible. But I do think that the way that is working now, there on the function list, it seems like that's how it's working. Is on the file system doc is gonna every time that there is a change, like let's say this file was removed from the folder here, it's gonna recreate the entire tree instead of just keeping the state and just removing the node. So traversing and removing. So obviously that the way that they did there is a lot easier to implement and a lot simpler, but is not very good. So I also need to change the function so that it doesn't clear the tree each time. So I have to see. I guess like I'm gonna be forced right away to think about the part that is the most difficult. I was trying to maybe I can see if there are other things like I'm trying to incrementally change obviously. So like because I don't want to think about everything at the same time. So I was trying to get everything to work first and then only later think about that because I know that this is going to be the hardest part about this. So I was trying to delete everything that is related to the file system, but I think it's probably not going to be possible. So I'm going to have to think about this now. Let me like quickly look for the other parts that I'm going to start from the beginning. And because I still didn't spend the time to study all the functions to see what they do. And also this file list here, I'm not really sure how it goes. I think that it is related to the files state, but I don't know why they did this other class here. I think this is the other class that they created. It's probably to keep track of the state of the files, but I'm not really sure why you use another class. Yeah, this is the one that I thought that it might be, but it might be because of the classes. I do remember that I spent some time on this, and I think it might be due to the way that the original classes from Godot works. That's basically the class that are already part of the scene. So based on the way that these classes work and the way that they update their state, it might be better to use these other classes here just to manage this state. But I don't know very well like, exactly what they are responsible for. Like if they have all the files on the directory or not. I think that the search seems off to me. So the search should be something that I move to the backend. Pretty confident on that. So makes a lot more sense. You still have so like it should be kind of like it should be a path thing, I think. This goes into another problem, which is the variance. So because I'm communicating with the classes through signals, it becomes more annoying, I think. True. Maybe I can create a function and then I don't use a signal, I just call directly from the other one. I think that's probably better. So like I can do the signal. I think it makes more sense for the search because it just like not 100% sure, but like it makes more sense for me at least to think about like the back end as being faster and the front end as being slower because the back ends like the back end should have a more clear view of the data. It's kind of like the same thing with operational system, and the closer you are to the hardware, the faster it's gonna be, and the more clear the picture is gonna be. So I think it makes more sense to send the request to the model for the search string. Then the model does the search on the state. And also, I think that it makes more sense as well because of the multiple threads. It's like the model is going to be the thing that is working on the actual state. So after you send the signal, then the model has a thread. The model filters the state based on the search string. And then but this is the part that is kind of annoying because I think here it has to be based on maybe I can put it on a function that returns but if I do it on a thread, maybe it's annoying. Because then I have to put a thread on the presenter as well. So maybe a signal is better, but the problem with the signal is that you're limited to the variance. So like I would have to emit a signal with the paths, let's say. And then the signal would be to the presenter. Then the presenter will call the function. I think it makes more sense to call the function directly on the view from the presenter to update the state. Hmm. It's kind of hard to think about this. I don't know if I'm overly complicating this or if there is something. The biggest thing, I think that it seems to me that there should be a simpler way to, like this, a simpler, more efficient way to do the work only one time, and then because the essence of the thing in my mind is the algorithm. So like, it's the algorithm and the structure of the data. Like the front and the back end is basically reflections of each other, and the only difference is the classes that are used to change the state. So it makes a lot more sense to me to only think about the algorithm once, the algorithm and the structure, and then to make each one of them reflect each other based on the flow of information between them. So I guess the question is, but you should. Yeah, so I think maybe that's what I'm saying. Like I should try to get the structure of the algorithm first. But the question is, can I do that without having to test everything else? And maybe the way that it is there is already that way. Yeah, because this is the thing, is like if I implement multiple threads and I have to progressively load the directory, then Maybe there is a maybe the difference is gonna be on the message for the front end. But the difference in message is gonna change the algorithm, I think. The way that is working now is the algorithm runs everything. I think that's the thing that is confusing me. It's like how to make it so that based on the state, because you can't change the algorithm, so I have to change the flow of the algorithms. I have to break down the function, I think. That's kind of the problem. I think I have to break down the function, and that's why probably that I'm feeling that it's kind of weird the way that it is there. It's probably like it works for the way that it was originally because you're loading everything at once. But I think if you want to load progressively, it probably doesn't make sense. It has to be based on the messages. So like the structure of the algorithm is going to depend on the flow of the message between the back end and the front end. I'm thinking about removing everything as well. Like, because it might be easier to start from the beginning. I'm thinking than to try to change this stuff. So like I should remove everything and then add one thing by one again. Because I wanna like remove all this stuff that doesn't matter to me now. The issue is that it might break the visualization there in the beginning. Like I should try to do that first, I think. So I'm gonna remove all this code. Like one thing that I did was is start using Git for this. I was trying to avoid, but I think it's just better to use. So now I'll create another branch on this one to do this. So if it doesn't work, I just go back to the other one. You should try to remove everything that's there is one function that matters there. That is the function that I think there is two functions. One creates the pop-up of the options of when you left click. The other ones that are annoying are the to move the files around because you have to create a like the icon as you're holding the thing. And there are some functions there that is kind of annoying to understand. They come from the control class. So this is one of the annoying things. And the other one is the function that has the it puts the callback functions, but I think that that one is also gonna have a bunch of other functions connected. But maybe I should remove those ones as well. Like it's basically when you right click the thing that creates the menu and the options. But I think I'm gonna have to do that again anyway, probably. So maybe I should remove and then start from the beginning. Because it might be a lot easier to think about from the beginning. So like remove everything and just get the class in the beginning from the update tree and create tree, which is what matters the most. Yeah, I think that this is one of the things that it seems that it shouldn't be this way. So if it is gonna be the way that I'm doing now, that I'm trying to do now, because it should be based on a state, I think, instead of the. Oh, but the thing is, the class already has like class is the tree structure. So it's gonna be reflected anyway if you change the. This is the problem, I think. Yeah, like when you delete. So maybe I should spend time trying to understand the remove functions and stuff like that. Just see how it works. So if I try to do things, obviously I am going to do incrementally. I think that the what is happening is that this class here is working as a bridge between the two. So like this is working as a flow of information between them. But I think the way that it is now, because it is working as the way of the bridge, because this class is working as the bridge, it is not very good to progressively do things. Because the state, but maybe it is. Like the state depends on the connection of these classes. So like if you remove a node from the backend, for example, you have to, but maybe I should create just another algorithm to traverse to that point. So like I could create an algorithm, for example, that receives this one, which would be the root, and then recursively traverses until it finds a pattern, and then based on that pattern, it changes the state of the node. See what ChatGPT is. I'm gonna quickly look into the other stuff. It's kind of hard to think about a question as well. So like I think that maybe I should keep the code here because it's gonna be like I can create just new algorithms that are going to search based on the roots. So I think the main issue for now is the roots, like getting the currents, because obviously it's easy to solve. You just create a wrapper on the presenter and then send the information. But it's more annoying to me, more important to understand like if there is a fundamental problem here, like on the structure of the thing. Because obviously it makes sense to think about this because it's gonna impact the optimizations. So like it's gonna, if I just do the simplest solution possible every time, then later on might be very like a lot harder to change because you need to change everything because there was a flawed assumption in the design in the beginning. That's what I'm kind of concerned about. And but the problem is that I can't quite find a way to ask like from first principles that I think I'm gonna get a good response from large language model or from a search engine on how to like solve this issue. Like the question I think is what is the best way to keep track of the roots? Like if this class should keep track of the roots, I think like it has to keep track both of the roots of the like the root path of the model, which for now is the file system, and it has to keep track of the roots folder. But does it make sense that it needs to keep track of that? It seems that it shouldn't, but it needs the path. The question is like it's gonna need the path either way, but one way would be to get the path from the model through the flow messages. So like the signal from the model makes the presenter call function from the view. And the other one, it would be this class has, I put member variables on the class, and then I just update the member variables. So like the root folder is gonna be only the beginning, but like maybe I will want to change this or I tried other stuff that allows you to change the root without having to remove the class from the class. Which probably that's gonna happen, but I think these functions I had to change because of the way that I'm doing here. Like there's different functions on Godot to find the roots of the project, which they use this special path here, and they designed the original classes to use only this path. But the reason why I had to change is because obviously I want to use any path on the operational system. This also kind of doesn't make sense. Like the name of the function is kind of weird. This is returning the model directory, and the name's get file system path. Which doesn't make a lot of sense. This should be the function that gets called after the folder is removed. This is the function that determines what is going to happen based on the options that you select on the menu. So when you right click and you select one of the options, it's going to run this function and it's going to change what happens based on the option. This had some annoying thing about the variants because I think that this is probably the main reason why they didn't subscribe this on ClassDB, the functions, because of the variants. So I think since it's using a vector of string, the variant doesn't support. So if you wanna subscribe on ClassDB, you have to change the function. And you have to subscribe if you wanna emit a signal that is gonna call the function as a callback. There obviously I can always call directly from the presenter as well. So I think that the connection between the presenter and the view is probably more often going to be like a direct function call from the presenter to the view. And the model should be more about signals, I think. Because the model is going to operate asynchronously with threads. So it makes more sense that most of the time it's going to send a signal to the presenter. And then based on the signal, the presenter is going to communicate with our call functions from the view. I think it's probably it makes more sense to the root path is like easy. Like, it's not that big of a deal. I think you should just put as a variable of the class instead of having the root there as this. So I can search for and then I can change. I can make it as a variable of the class, and then I can make it based on the signal. So like as I initialize the class, I can pass through like either put it as a function or both put it as a function with setters and getters, or put on the constructor and then initialize when I initialize the class, the presenter class, I update the root for both classes. Also, that depends on. Yeah, but I would change. So it would be just a variable of the class because it's going to be updated based on the button initially there, or it's going to be based on the cache. Share both. So, this is another thing. Should I move the cache to the presenter? Not really sure if I should. I think probably yes. Move the save config to the presenter class as well. But obviously the button is gonna be on the front. But obviously I can make it as a variable. I think that the part that is more confusing is not the root, is the place where it needs the state, which is the class that represents the root. So maybe I should change the function so that they accept that. But it feels kind of weird. I think that the weird thing is that the asymmetry is the trans. That's the problem. So I don't think maybe I should ask that first. So does it make sense to use trans on the front end as well? Because the problem is that if I make the function on the front end load everything, then it can't. If I make load everything, then it can't receive the. Maybe it can actually because The root one, the root class that has the state of the root directory is going to be is already going to have the state reflected on it from the model. So it's not gonna matter like how fast it is, but I do think that it probably matters actually. I don't like the idea of coupling them. And if you pass the, if I make either as a variable or if I receive as an argument the, yeah, but I think like there needs to be a connection. So is I think it's either one of these two options, either receive the state, but maybe I should try to receive the path instead. That's probably what I'm thinking about. That is kind of wrong. Maybe that's the core of the issue. Is that right now is like I'm getting the class from the model using the object that I created here, which doesn't make a lot of sense. I should just get the path instead. But if you get the paths, I think that's probably the main difference because right now the way that it works is based on the functions that get called from the roots. It should be probably based on the paths, and then you send the paths as if you have pipes between the back end and the front end. Because if you send, I think the main difference is that if you send the paths, it allows you to have more flexibility on how you update the front end and how you update the back end. Because you can update the back end with asynchronous in multiple threads, and then you can have a different state, and then you can from that state you can send the the paths of the things that were already. It just seems that it makes more sense to me instead of sending the whole object. Yeah, because I think that the object is the thing that forces the coupling between the classes. Because if you want to access the object, then I need to either have an instant reference, and it's not very good to have the reference because then I think it increases the uncertainty of whether or not they're going to be synchronized properly. That's the problem. So it's like just a more clear way to think about if you have like the class separated on the back end and then the class sends the paths because the front end only uses the paths to create the tree. But so I think I should like do the algorithms to traverse based on the paths. So like they should be separated, I think. So create the state of the classes based on the path structure on the front end. And then on the back end you make it based on the class. But maybe I should have another structure that creates because I can reuse I can like maybe that's the easiest way possible actually. So like because here is gonna be like each one of these on the model is gonna be a single class. Like each level is based on a class. So each folder basically is a class. And the class contains the subfolders for that level and the files. So I can create like another structure that I send to the biggest problem is the variant. It's like how to send the data through the signal. But maybe I can cache that on the maybe I can create a cache. I think that's probably better. So in order for me to not be bounded by but I think that's I would have to be bounded anyway. But I think that this direction is probably the best way to go. So like on the back end you have the class as like their state for each level. Then you use that as I'm creating the state from the scan new directory on the model. I have another data structure on the model that keeps track of the levels and the paths. Because then this makes it a lot easier to build the classes on the front end. Because the main thing that the front end needs is the strings. It needs the strings with the metadata to determine like what's gonna be the name of the folder, for example, and it needs the structure. Yeah, but the problem with that is like, what if you rename the folder? Yeah, I guess what I'm doing is just basically creating a level, like another abstraction that would serve as like would be like a structure that is outside of the tree. I think that's what I need to think about. What is the best structure to synchronize both? Because then this one would serve as the bridge between the front end and the back end. Because that way, I think I need to do this because they need to be. I need to decouple the way that the algorithms work. Because if this one depends on the class, then it kind of forces the algorithm to be the same, I think. Like the state of the front end has to be the same, which means that in order to update, you need to do the same thing, which doesn't make sense. But if I create another data structure, then allows me to change the model however I want. And then what is reflected to the front end depends only on the other structure. So like for example, when you have a file, when you some like when the user renames the file, oh, that's the situation I was thinking about. That's uh, because of the structure, it would be harder. But like it wouldn't be, maybe it would be the same thing as having the tree. Because it would have to send the signal, and on the signal you would need to have the information as well. What level was changed. But maybe if I send the path is enough. Because the path is going to be the same. So I think I have to create algorithms by traversing by the path. Yeah, so I should probably create something to filter the tree from the paths. Or traverse the tree based on the path. And then I do the synchronization between them based on the path. The question is whether or not it makes sense to like send the object to the like I think if you want to send the object, then obviously I think you have two options. One is to make the object as a member variable of the front end. Pass your state. And the other one is to make the functions, the algorithms from the front end to depend on the thing as an argument. And those are the two options. And then I would call this from the backend. But I'm not really sure if I'm overthinking on this situation here because like for me it seems that if you need to have the object on here, then it's probably gonna force you to have the like same mechanism to synchronize the two things, and I think that they are different because eventually you want to implement virtual scrolling on the front end. So I think that the way that you manage the front end state is going to be different than the way that you manage the back end state. And I think if you do the algorithms based on the roots of the node on the back end, it kind of forces you to have. But the question is, does it force you? Sure. I think it kind of does because then you're going to do everything based on the state. So like if I have a thread, for example, and the thread is changing the thing, then it is gonna fuck up. That's the problem. Because then the algorithms are gonna be based. So let's say that this this thing is loading the tree, so it's doing everything like is based on a linked list. Not a linked list, but it just like creates pointers to the class between the classes, I think. So the root one it contains the state and then links the level below and then so on, so on. So if the model is loading this one, and then as the model is loading, I want to run the update tree. Then let's say that one of the nodes is removed or whatever. Like as this one is traversing, it's gonna create a data race. I think that's the problem. So like if you make a direct mapping, is not very good, I think. But if you create another data structure, then you have more room to like update asynchronously, I think. So I think for that reason, it probably makes more sense to try to separate the things. But the reason why I'm kind of reluctant to do this is because it feels kind of weird because either way you're forced to have a tree data structure. That's the kind of problem because you need to keep track of the levels. So I think that the best compromise is probably the path. So you make the search based on the path, and then you make the structure based on the path. And for the structure, you need the tree level though. It would be easier if, as I'm traversing this, I keep track of the paths, of the levels and the paths. But then, like, what's the difference really? So maybe the best way is to create another function to, like, instead of putting the roots on the thing, I just create. But then wouldn't it be the same thing? I think the problem is the data race thing. It's like since you have the pointer as the root, it doesn't make sense. So maybe one question that I can ask is whether or not does it make more sense? Model view presenter. Make the view states based on the model. And maybe this is what I have to ask. I think I have to think about this now because I'm kind of forced to. There isn't like I can change the path, but it's gonna go. I think like this is the core fundamental thing that I have to think about. Like once I figure this out, and once I make this clear, everything else is gonna be a lot easier to change, I think. Because the structure of the algorithms is a direct reflection of the flow of data between the classes. So like the way that I'm gonna think about how I should do the algorithm in the first place is gonna be dependent on the flow of data between the things and how the model is gonna be updated. So like there's two main optimizations I think that's I'm gonna try to do. Like one is the virtual scrolling on the front end. So it's based on the scroll container, which I might have to add again. I have a scroll container on the dock outside of the class, but I might have to add a new one. But maybe not because what I can do is just get based on the. But it might be necessary because like yeah, I have to listen to the event. So I'm probably gonna have to put a scroll container on the view later, and then basically you get the size of the viewports, and then you get like I think the simplest way would be you just calculate the width of the cell or the height of the cell, and then you do the math, obviously. So you get the whole width, and then divide by how many cells you have, and then you do some range outside so that it doesn't lag. Then you only load on the current level whatever is visible on this range. So this is one optimization. And I think that there are probably easier ways, like there are probably functions to get the more precise version, to know how many to load roughly. And I think ChatGPT recommends you put everything on a buffer. So you have a buffer, which is basically the size in memory of this, which is basically how many items. So it works kind of like a queue. And then as you scroll, you listen to the scroll and have a callback function that changes what shows, which item shows. So you do the surface view on the items, on the base direct as a direct reflection of the queue, and not the. Yeah, but the thing is, you need the depth as well, so you need both. So because each one you need to keep the consistency obviously of the structure of the folder. So like a two-dimensional thing. It's like on the back you would have the. So obviously you have the depth and you have the. It would make more sense to do the other way, but like this here. So for the depth, because the depth is only matters for the unclassed paths. There needs to be like the direction, like you need to find the optimal way of like how many you need to load for each time, which depends on the. So like the front end has the uncollapsed paths and it has to send that information to the back end, and the back end has to have a range. So the same way that there is this range here on the front for the scrolling that goes beyond the like what is visible, you also have the same range on the depth. And the depth is based on the 3D data structure and on the uncollapsed paths. As obviously you can choose different. As soon as you have more uncollapsed paths, then you're forced to show obviously. But then there's another thing like it's kind of like you're taking this view here and then you are navigating through the data structure based on the view. So like the view highlights I think the width is the levels, which is breadth first search, and the depth is the recursion, which is that first search. So as the view moves, you're traversing the tree on this diagonal way to determine what you're gonna show, and then you have the control flow, which is the flow of information of the uncollapsed paths on the front end. So the problem obviously is like how do you synchronize both? Because I think on the view, that's the thing. The view doesn't need to have the same state that the backend has. So like usually like either the backend is going to be exactly the same as the view, but probably not. I think usually it's going to be this distance here where you're going to have more data on the backend, like some room for flexibility, but you're going to have to dynamically change based on what's happening on the front end. So like the backend, I don't think that makes sense to load the entire thing either. So the backend is gonna depends on the size of there should be a heuristic based on the size that determines how much is gonna load. And the width, and this is the thing that I'm talking about. I think this is why it's kind of annoying to think about because like the level of the breadth first search on the model is directly correlated with the state of the view. And what determines the connection between them is the flow of information, which is done through the signals. So like I can't just do the algorithm for the buffer, like because obviously the easiest solution would be you do buffer search and then you just go over all the children on the model. But that doesn't make sense if you don't want to load the entire state. If you just want to load the range, but then it changes the structure of the algorithm because then you, instead of doing the whole buffer search for all the levels, you need a heuristic that is gonna come from the front end, and then yeah, I think you should put the thing on the argument of the function that is gonna determine the control flow. It's gonna limit the range you're gonna loop over. But then it's not only that because it depends on the level structure. So like if you scroll down, then obviously it has to change the range. So like the window should determine the value inside of the control flow. So like when you do a for I loop, I think the beginning should be determined by the probably highest point on the view. The thing that makes it hard is that obviously it's gonna change depending on the state. That's kind of the problem. So I think the question to answer is how is the relationship going to be between what is passed on the bridge between the two and how that's going to change the structure of the algorithm. I mean, maybe you should do. I think you should do a pseudo code on the model first, then think about this range of things. So there's both the breadth and the depth. I think the breadth is more important in the beginning because you need to make sure you load the first level first, obviously. So this is the thing I think I have to change the way that it is there. But maybe it's already because it's both looping and doing recursion. So it's kind of doing the same thing. But I think it should be breadth first search. The problem is that it changes based on the way that the structure of the directory is going to be, obviously. But I think either way, you need to. Yeah, I think it has to be breadth first search, limited by the range that it shows up on the level. So I think that's what I have to clarify first. It's like what is usually going to be. You need to calculate first on the front end the max height and minimum height, then divide by the height of each cell to get the number of elements. Then you have a heuristic for a range outside of that you want to load. Then you set that as the maximum. But then how do you determine what is going to be the first level, like the first one on the level? I think you just make it, yeah, but then like it depends on the state. That's kind of the problem. The question is like, do you remove from the model as you scroll back? So this would be one of the questions. All right. I think that the question that I have more is like how would you know? Like I think you have to load everything in the beginning. That's kind of the problem. It's probably it has to be based on the way you put there. So it's based on the string, I think. The issue is like how do you keep track of these states? I'm pretty sure that VS Code opens from the position that it was before on the one that shows in the top here. So the question is like how do you keep track of that? I guess it's just not very hard. So you just put yep. It's not very hard, but as usual, there's multiple different ways to do it. So that's kind of the hard part, is figuring out what is the best way to do it. But one way would be to just keep a cache, obviously, of. So like maybe I have to think about it from the beginning first, because it's easier to think. So in the beginning, you're gonna have it's gonna depend on the order you're putting the folders, which is probably gonna be alphabetical. In my case, it's gonna be based on the dir axis, the way that it traverses. So from that point, the top is gonna be obviously the first, and then the bottom is gonna be whatever range you have. Then as it scrolls, so you need the queue. I need to have a queue on the backend that has the range. And then based on the queue, the first and last elements. Yeah, that's the easiest way. So the size of the queue determines the width of the broad first search. So maybe I could do. This is another question. Should have two functions or one? Probably I'm gonna have more, but the beginning to load the directory. I think I need to have the. Well, I'm just gonna think about the first, obviously. Then if I need another one, I do another one. So I think I need to create a queue. So create. But the thing is, I'm gonna have to use a list, I think, on Godot because of the methods. I can implement the methods on the vector, but it's gonna be annoying, and I don't want to do that. And I don't like using the list because, from what I've seen, is not recommended for most cases. It's better to use a vector array. But I'm thinking I'm just gonna use the list because it's easier to implement a queue thing with the list. So in the beginning, you check to see. You check to see. Yeah, but if I do two different functions, then I wouldn't need to check because it would always be empty in the one that loads the state for the first time. But I think it does make more sense because then it makes more sense to check because then I'm probably gonna put the configuration on the presenter and not the view. So if the configuration is on the presenter, I'm probably gonna have a method on the model that's gonna be that is gonna update the size of the queue based on whether or not there was a cache before. Then based on that size, yeah, I would have to cache the last element and the first element. So I would first check to see if there is, or actually I could have another function that just you wouldn't recreate the size. Maybe I could have another one that recreates the size based on the last one and the first one. So the question would be, like, if it is a level where, let's say you scroll down, so there's other folders on top of that, how would you know? I think you would create an algorithm that gets to the level doing breadth first search, yeah, but then it would take a lot of time. That's the problem. So I think probably the best way to do is just keep track of the first and the last of the width, the visible range. then you start the algorithm based on the visible range. Yeah, but then like how do you know the ones before? That's the problem. Because like in this case, for example, when you're doing breadth first search, like if this was the top one, let's say, from last time, and then I would need to have a range on top of this one as well to load. But on by the time that I get to this place, I would have passed the other ones already. So maybe I could do the heuristic based on another data structure. So I can just move the queue as you're going based on the range. So like as you traverse the tree, you put the nodes that were visited on the same level on that range until you get to the points to the point of the last visible item on the top and the bottom. So you always keep, or you just do the queue based on the range anyway, because it's gonna be the same. But I think depending on the situation is gonna change the way that you do it because of the structure of the directory. I think that's the thing that makes it more confusing because you have both breadth and the depth, and the algorithm can pick and choose obviously. So it has to be some heuristic that is based on the context. I think that's where the complexity is. So like for example, if you have a situation like this where I have a folder like this and the folder is very nested, it wouldn't be to show what's visible first. You have to know like the most effective way possible. If you want to show in the most effective way possible, you would need to know the levels of the visible range, because if you're doing a breadth first search, it's gonna go like horizontally first, and then like you would go straight from Brahma to all these other files here, instead of when it gets to Brahma, going deeper. So I think I need to do recursion based on the roots. So I need to see first if it is open. Yeah, so I think it's good because it's making more clear to me what I should do. So based on range, I think that the trick, the part that is kind of hard is figuring out, because on each circumstance, on the depending on the state that the thing was at last time, is going to change how you get to that point from the tree. But I think I can get based on the path. So obviously it would be better if you could get based on the path and then go back from that point. Because the thing that makes it hard is the range you need. The range and the depth. So each circumstance is going to be different. So like if you do on the algorithm way to get, like you can use the D axis for example to get the whatever is the top item. This case would be this one. But then I need the range on top of that, which the range is gonna depend on an infinite amount of circumstances, because this item could be parts of a nested folder or could be on the top of the directory or stuff like that. And the traversal from this path to the root is the thing that is gonna matter, because you need to load the range, but you need to load only the visible stuff. So it's a combination of the uncollapsed paths, the structure of the tree, of the levels, that is directly correlated with the unclassed paths, and the top and lowest items that show on the level. So like the queue has to reflect only the surface level of the tree. think I'm gonna stop streaming soon. I'm gonna have to spend a bunch of time thinking about this, I think. And maybe there is easier ways to do this. I think like once because this is the hardest part about this is solving this thing here. Like the structure of this impacts everything, and I think this is the fundamental principle of this problem. That you have the visible range, and then the algorithms and flow of information between the classes is going to be directly correlated with the visible range. So I have both the graph, which is the surface level that shows, and you have the depth, which is the structure of the tree. And the structure of the tree is going to is going to converge to, is going to either converge or diverge or both through infinity, because you can have an infinite amount of variation of kinds of trees, final trees you're going to have. And it's like you're traversing that structure. So the algorithm is going to be a direct reflection of that. So that once you figure out what is the optimal way to create the algorithm to like both have the cache on the model and to load initially based on the previous cache. I think that's the thing. So once I have a clear picture of that, then it becomes more like I think it's easier to think about how to send the information from the front end and the back end to reflect that state. That's the thing. And this is directly correlated with the root node there. The question of whether or not to keep track of the roots or create another data structure on this file, on this class here, is directly correlated with this information flow between the classes, because that's directly correlated with the structure of the algorithm. So I think that the reason why I don't like it very much to pass the thing is because of that. I think if I pass the thing, the node, the root node of the model class that keeps track of the state of the tree, if I use that either as a variable, either as a member variable or a pass as an argument, I think both of the situations is going to force me to have the same structure or similar structures of the algorithms to deal with the updates. That's the problem. And I don't want that because I want them to be separate. Because I think that the optimizations you do on each side is different. So it makes more sense for the algorithms to be different. So if that's the case, you should probably have you should have another structure, but then that's the question. So like whether or not should, because I guess like you could make the argument as well. Yeah, but I think if you do it from the object, it increases the chance of data races between the front end and back end if we're doing things progressively. I think you need to have two separate things, and then you need to have an information flow between them. The question is whether or not, because you're gonna need the data structure as well. That's the problem. This is the thing that I'm thinking, is that like probably maybe on the front end you don't need the tree, you just need the queue. Because it doesn't make sense to have the whole tree on the front end. Like why do you need the tree if you just want to display what's visible? I think that's the key to this. So I think that probably this is the thing that is wrong. So in the front end you don't need the tree, because the front end is a 2D surface. So you just need the queue. Like you just need one level on the front end, which is going to be the thing that shows. And it does need the depth of the tree, but that doesn't necessarily mean that it needs the whole structure of the tree. It only needs to know the depth to the extent that it's gonna. Yeah, but the depth comes like because you do need to create like a based on the way that the classes work there. You do need to know the depth so you can create the tree items in the correct way, which I'm not really familiar with. I'm gonna have to spend more time as well studying this. It's basically this class here, like the way that this class works shapes what shows up on the front end there. So like you do need to have the depth on the uncollapsed paths. But I think that this should be done through the information flow between them. So like the way that I see it is that the model, it loads like more stuff than the front end needs. So the front end, like obviously, let's say that this is the extents, like this is the roots, and this is the first level that is going to show there on the first time that you open the editor, for example. It shows the root and it shows the first level, and those are the two subdirectories that it has on the first level. Let's say it has a file as well. So in this case, the way that I'm thinking about is that usually what's going to happen is that you want more things to be loaded on the backend. So in this case, it would be this wouldn't be loaded. This would be the stuff that is loaded in the beginning on the front end, the stuff that you need. But on the back end, you load a lot more stuff. Not a lot more, but a decent range, so you have less lag. But you don't want to load everything if it's a large directory because you want to save memory and you want to make it faster, obviously. And also you want to load in the background as it shows on the view straight away. So so the model would have all of this, and the front end would have only this. So I think the best way to do it is like the structure on the model is the whole thing, but the structure on the front end is always only one level. But then what changes is obviously when you open the directory. So when you open a folder, it's going to be in collapse, and you're going to have to review the next level on the model. And then it's going to be like this is the part that is the information flow between the two. So as you uncollapse the paths on the front end, you need to send the information to the back end, and then you need to get from the cache on the back end the next level, and then send the next level to the front end for that directory. So I think the algorithms that you create are based on the paths. And it always keeps one level based on the folder that was uncollapsed. But the problem is that each time that you uncollapse a level, you need to keep track of that. But you don't want to necessarily keep track of that. That's the problem. Because when you scroll, you're gonna be like you don't want to keep like you don't want to have the whole state on the front end, because as you scroll, you want to remove the stuff that is not needed. And that depends on the level. But I think so maybe the key part is the uncollapsed paths. I think like uncollapsed paths works as a level thing. So it should be. I think the answer should be on the flow information. So you should have the uncollapsed paths. They represent the levels. And then you have the path, the file or folder paths, which is the queue for what's visible. And as you scroll up and down, what changes the state of the model in the front end is going to be the information of the unclassed paths. I think the model always has. The model always has a bigger range. It's also going to depend because if you open more, you're going to expand, obviously, what is loaded on the model as you uncollapse the paths. And that reflects the cache. So like this flow of data of horizontally going back and forth and uncollapsing paths, like this line here, is what determines the structure of the algorithm. And this line is the input, which is the user interaction. So I think that this line is reflected on the flow of data between the algorithms, the signals, and is going to change the structure of the algorithm. So it's probably going to be like based on the arguments of the functions. The arguments determine the how do you draw the line, which is probably through this. So like on this case, on this coordinate system here, it would be the x is the unclassed paths, which is the levels, and the y is the file folder paths for each level. So you would be like a hash of a vector. So the key would be the level, which is the unclassed path, and the value would be a vector, would be the q. So it's the list. So as a hash of the string or string name, which is the level, should the list. Yeah, I think this is probably. Well, the problem is the variant. So they can't use the hash map on the variant. Can use dictionary. So if I want to use this, I can make it as this, but then indirectly save whatever needs to be saved on the configuration through an intermediate step. So another algorithm that translates the hash to another data structure that I can use to save the information on the configuration file. So I can translate both of them. Yeah, but I think that this is probably the key. So I need to structure the algorithms based on the hash map of the structure, which is the line, basically. So the line is the data structure of the navigation, which determines like what's gonna happen as, because it's kind of like a projection of the scroll. So as the user is scrolling down, you're showing the projection of the line. Yeah, I think it's becoming a lot more clear on my mind how it works. So I think that this is the thing that is making me think that's probably better to separate. So I shouldn't make the front end should be dependent on the node, on the same node, because it's a different structure. I think I need to spend more time thinking about this because it's related to the topology. It's related to topology types and category theory. So like this path here is a function, and then you have two different data structures. They connect them. It's very interesting. Yeah, so I think that the configuration has to be on the presenter because of that. So like in the beginning, the first time when you don't have the configuration, I'm gonna write this stuff down. So I'm gonna write here. Just you loads the model initially from the Q hash map pattern. First, when you do have, but in this case, we wouldn't need to get from the view because you would have the configuration. So it would be basically the same thing. So you load the model first, but then load the model. So I was thinking that when you have the configuration, maybe it makes more sense to load the view first because you need to know like the thing, but it doesn't matter because you're gonna have the configuration on the presenter. So it might be the same function as well. The only thing that changes is the argument you pass. So I pass the configuration as an argument, and like either way, I just pass the configuration to the model. Then you check to see that based on the range and the configuration, it's going to create the path. Like it's gonna know the path based on the range. Because this hash map here creates the structure of the line. And then based on the structure of the line, it determines the structure of the algorithm to load the data in the beginning. Because the data is always going to be like it should probably follow a projection of the, not a projection, but like the same shape as the line to determine what's going to be loaded, but with room from, which is like the lagging difference. And then this line would determine how the algorithm traverses the tree to get the paths. So for like this would translate on the way you are doing the heuristic to traverse, because the way that you works for traversing a tree is basically like it's not very difficult. The most difficult part of understanding the traversing the tree is backtracking, because recursion is very confusing when it comes to backtracking. Because it's not intuitive to think about backtracking. Just basically, when you hit the base case of the recursive function, it's going to continue executing the function from that point. But the reason why it's very hard to think about it is because of the side effects that the function has and the mutation of state. So both of these things make it a lot harder to think about the recursion, because it's not easy to keep track on your mind of the what state it's going to be when you hit the base case and how that's going to affect the rest of the function. But it's very easy to think about it. Like the traversing, this case is kind of weird because I did the way that I did the tree, but if you had the tree in the normal way, doing the recursion is just going horizontally first. So that's how I think about it. The recursion is like the y direction, and the loop is the x direction. And obviously they are both the same, they're reflections of each other. The biggest difference from a fundamental principle perspective from the recursion to the loop is the stack frame. So like is the convention of stacks on the compiler. It's just an abstraction, because both of them are going to be labels. And the difference is that the function receives arguments based on the calling convention of the compiler, and the loop is just a label that goes backwards. So loops obviously are also the same as branches. But the fundamental essence of computing is just calculations on a line that have if-else statements, have an option, a branch. And then the difference between the branch and the loop is a branch that goes backwards in time. So the reason why the recursion is different than the loop is that the calling convention creates the tree data structure because of the flow of information of the arguments between the stack frames. So the main difference is the scope between them. And I think that when it comes to the traversion of the tree, the difference is going to be on the arrow of time because of memory consistency. So I think that's why the Fourier transform translates I'm not really sure if it's the Fourier transform, but like drawing a recursion is like drawing a loop on a different axis. Like there are different dimensions of the same thing, because what changes between them is the reference frame, and the reference frame is encoded on the variable, on the registers that are passed as an argument to the function. So I think that's the reason why the tree creates the recursion creates the tree data structure, and the loop doesn't. But I'm not really sure if it is because of that the recursion it goes on depth first. And that's what I'm thinking about now, is like why do I think that does make sense, like just intuitively. And I think it has to do with the structure. Yeah, because when you're looping over a different structure than when you are recursing. Yeah, it's because of the arguments. So because you only pass one argument to the recursion at a time, that means you are going to go in depth first. And when you're looping, it's like you're passing all the arguments at the same time, because you're doing inside of the loop on the iteration. So like you get the levels. Yeah, so the difference in navigation on the tree is going to be determined by. I'm not really sure if on higher dimensions you would have. Yeah, I think it would probably be the same thing. I think that for higher dimensions, it probably changes based on the data structure you're looping over. Yeah, but the way you traverse is going to depend on where you put the recursion and where you put the loop, and the heuristics inside of each one. So basically, the control flow allows you to go diagonally between them, because the control flow is the thing that is going to determine at which point on the path you do the recursion or you do the loop. When you have two dimensions, which is a tree. And this is the stuff that I'm saying here about the line, is that basically this is why I'm thinking like this, because on that situation there, I think that you're seeing things on the X frame, because that the X is the surface on the screen, and the line is the line of the navigation between. Is the navigation of the tree data structure is the path that creates by the movement of the scroll container. So like the two-dimensional screen is the projection of the tree. The tree projects to the two-dimensional screen through the path based on the collapsed paths. And the shape of the recursion, or the shape of the heuristic that determines the flow of that you do on the tree is determined by the shape of the path. So the data structure shapes the heuristic that you choose for traversing the tree. And then the cache is just the same shape, or probably then this is the thing that I think you can use probably machine learning as well, because you're just gonna like encapsulate the gravitational force, which is basically the inputs are gonna determine the shape of the projection, like the lag room you have, which is going to be the difference between the model and the view. Because obviously in the view you don't need the cache. But it's good to have the lag because when you open, it's more responsive if you have like more depth. But this obviously depends on the shape of the tree as well. But I think the fundamental is always going to be the same. Like what matters is figuring out the shape of the path that you need to show, which is the projection, which is determined by this data structure probably on this case. And then based on this, it's going to be reflected on the algorithm. So you need to encode the data structure inside of the function. That's because that's what's going to determine how you traverse the tree. Then after you do that, you send the signal to the front end to load this stuff. So another thing I'm thinking about is whether or not it makes sense to have the classes there if I do like this. I think it still makes sense because on the back end it makes more sense to have the objects that represent the state. Or maybe it is better to do everything based on paths and then you don't need the objects. That might be better actually. The question I'm having is whether or not it's necessary to have. Isn't the only thing that matters what shows on the screen there? But you need I think like the classes make it easier to encapsulate the depth, which is the tree. So maybe it's just easier to have the classes, I think, on the back end, but on the front end you don't need the class, I think. Just do a queue and then you do based on the levels. You do based on this thing here. So based on the hash map that determines the path, you load the queue. I think like it wouldn't be. The problem is you need to. I think I have to clarify how the class works there, how the tree item class works, because it becomes a problem when you. There are mainly two situations. One is when the visible stuff is on a deeper level than the stuff that is not visible, and then the other way around when the visible stuff is on a higher level. I think it's easier to think about when the visible stuff was on the higher level, because then that's obviously easier to create a class. You just create from that level. And the question would be though, like, because maybe it matters, like the amount of levels you have. Maybe you need to keep track of all the levels. Yeah, this is kind of the problem, because like want to be limited by the way the class works here, because the class is going to be the thing that determines like how it shows, and it has to be consistent obviously. But if I had the information of the levels, then I could. Yeah, so I need to see. I need to figure out how does this determine. How does the tree item determine whether it shows the thing or not? I need to understand more the mechanism on the tree item, how it displays everything. Because I need to know if I need to keep track of the state. Yeah, I think I kind of need to. That's kind of the problem. I think regardless of what's showing here, I have to keep track of the like the highest level so I can keep the same structure that is going to show there. And if that's the case, then like you can't really do the virtual scrolling thing. Because virtual scrolling would require to delete the items that are not visible, but then keep the structure. So I should ask more about this. Should ChatGPT probably. I'm just gonna comment out these dialogues here. These dialogues depend on the. So I'm gonna do everything different. I think the biggest question that I have to answer now. I'm probably gonna stop streaming because I've been here for a long time. But the biggest thing that I wanna answer, I think once I figure this out, it's gonna be easier to think about the algorithms. Like just thinking about this structure here already helped a lot. Because now I think I understand much better. Uh, I think the fundamental principles, I have to figure out the shape of the curve here. It's going to be a data structure. And this is going to determine how much of the tree you need to load. Then this is going to influence, I'm not really sure how, but I know for sure that it will influence the how the structure, the control flow inside of the algorithm that traverses through the tree should be, because it's basically the same thing. But the biggest thing that I need to figure out is on the visible range that is on the front end, so the range between the highest element and the lowest element. If you have a item that is like deeper on the visible range, and let's say you have let's say you have a node here on the middle, the visible range, like very like in depth inside of the thing, and then on the outside you have this node here. So the way that I'm thinking about, like I have to, like based on the way that the tree and the tree item class works, what would be the best way to make sure that I don't need to keep track of the whole structure of the tree? Because if I need to keep track of the whole structure of the tree, then it doesn't make sense to do the lazy loading because you have the whole states and it wouldn't matter. So in order to be able to do this, I need to simplify, like whenever the items go outside of the visible range, I need to keep the same layout on the visible range, but delete them from the range that is not visible. But the problem is that I think based on the way that the tree item works now, I think what would happen is that it would change the visible range. I think probably the answer to this is that like they're gonna be kind of reflections of each other, I think. What shows on the front end is gonna be the shape of the curve. A data structure that I use to show. I think the question like it's probably you would probably be the same thing. I think I still need to figure out either way how to keep the same structure, but delete the things. I think that the answer is probably the model. Yeah, it's probably the model. That's the thing. Yeah, but then like it depends on the way that the tree item works either way. Because if I keep track of the state on the model and then I just send a message to the front end to load, I still need to keep visually the same structure. That's the problem. I can create dummy nodes to like create the illusion of the level. The path is the thing that matters, I think. It's the path that matters because once I know the path, then the algorithm on the front end is gonna be like creating the illusion. Maybe it is better as well to have always the same kind of level, like from the visible stuff. Because this is something, maybe it might be better actually. I should try to do this. Because a lot of the times it's very annoying if you have like very deep levels, you need to scroll. So maybe if the range, the visible range is always the same thing. It's already like this here. No, yeah, but here, the difference would be like when a situation like this where you can see levels. In the case that I'm imagining, because of the way that the tree item works, you would put everything on the same level here. As soon as the cache stuff that is outside of the visible range gets deleted from the front end, you would move all the items to the left here, I think. So the question is like, how do you keep the layout, but are not forced to keep to have the whole state outside of the visible range? That's the question. But I think maybe if I can do it, like if I keep track of the levels, that's the only thing that matters, I think. I keep track of the highest level from the current items. The level on itself would already have the highest item. Because the zero would be like the root, and then each level after that would be just like the level as it says. So in order to keep the same layouts, I would just need to like recreate the level. So I create a fake root, let's say, on the outside of the visible range. In case it goes beyond, in case it goes below, I think. Yeah, so instead of keeping track of the whole thing, I just artificially create the levels by creating fake tree items outside of the visible range. So the main thing that I need to know, I think, is how does the because maybe it's already optimized. I'm not really sure, but I think probably not. I think it's most likely not optimized. I think that's based on the whole tree there. So like superficially spend some time looking at it. It's basically this function here. And so I think it creates the root from the create tree in the beginning. And the way that it's gonna show is gonna be based on the every time you create the. So I should flow. I should look for the flow. I think. Should probably go over with the debugger and then put the breakpoint there, and then see. Like try to clarify this first, because obviously the other thing that I can do is just change the class so that it works. Because like this thing about the levels would be just like the easiest way possible would be to just calculate how much it puts the level there, and then I just artificially create based on the level. So like the level would be the x on this situation of the. So the hash map would translate. Like I would keep track of the x and y dimensions based on the navigation, and then I think the question that I need to think more about is what is the best data structure to keep track of the. I need a data structure that's gonna allow me to encapsulate the path of the. It's based on the unclassed paths and on the width of the visible range, or the height of the visible range. That's basically the path. So each unclassed path creates a level. So it creates the x in this case, because the x is the how further apart it shows each box. And maybe this is the best thing to do. Like, I should study the way that they did the tree and tree item, and then just copy the classes as well in the same way that I did with the other ones. And then I just change the way that that is drawing, so like to represent what I'm thinking about. It's like the movements of up and down is going to change the x, which would be the levels of the tree to display, because that way you don't need to keep track of everything. That's the thing. Like I don't want to have to keep track of the root of the tree in order to show the visible range in the correct way. So it should be based on the x, which is the depth, what level the folder or file is at. That calculates how further away it's going to be from the other elements. And then the y obviously determines the visible, like the paths that should be shown. So it should be a queue only with the paths, which is the stuff that is going to be shown. And then you should have for each one you have a map that has the level that is shown, and the level is the x. So the queue is the y that has the paths, and the levels are the x. Then as you scroll, you just change the x. Yeah, so I think that's probably the best way to do it. Then I'm probably gonna have to, I think I'm gonna have to change I'm gonna have to create another class. So I'm gonna have to create a new tree and tree item, I think. But I'm gonna see first, obviously, how they did it. But I think that's probably not like that because of the way that I've seen there. So the way that it works, as far as I understand there, every time that that you create tree, like it creates based on the element you pass through the function, through the create tree function. Oh, I forgot to have to fix the thing there. So I'm not gonna be able to see. So I'm not gonna do this now. So I was gonna see like, or maybe I can see from the editor, because the editor is the same class as the tree. Yeah, so it doesn't show, but the thing obviously that I don't know is that whether or not it still has. I think that most likely it still has the state of the whole tree when it's not showing the items here. Now, obviously, what I'm talking about is that like, as soon as the items are not, it would be on the visible range and then some range outside. But as soon as they are over that range, I wouldn't load them. I would delete them. So I think the best way is like you keep a queue with the range you want to show of the paths, and then you have yeah, and then you make the x here, the distance between the levels. Uh, but this is the other thing because the problem is the connection between the nodes as well. If you just have the queue and the level, then it might mess up the order in which you do things. Yeah, so you kind of need to keep the. Yeah, but if you do a linked list, then you link one node with the other. That would be the queue. And then yeah, so if you do a linked list, it solves that. Double linked list, because then you make sure you keep the order consistent of the folders. I was thinking about if you want to reorder, but I think that it doesn't matter that much. One, and then if I do want to do that eventually, you can just do it based on you can maintain the linked list consistency, which is the pointers, and then just change the order of the nodes inside of the linked list. So I change the order in which you render each one based on whatever pattern you want. But I think that's probably the best way to do it. So you do a linked list, then links paths, which is basically strings of the name of the thing, or just a linked list of the names, and then you have the levels as well. So I link a list of the names where each node is connected to the. Yeah, but then how that the question is how do you build this? And I think that's you build it through the traverse. You build through traversing the tree on the path here. That's the answer, I think. So like the model, the actual model has the tree data structure, and then the front end is just a reflection that encapsulates the path on the queue linked list. So it has the connection of the sequence of the nodes based on the path. And this is the key, I think. So yeah, the key is the uncollapsed paths that I built based on the cache, the config cache, or initially on the model, and then I just built based on the reactions of the signals. Then based on this path here, I structured the algorithm on the model to create the tree, to load the tree data structure up until that path. And then I send the information of the shape of the path to the front end for creating the queue linked list based on the paths. So the surface of the thing here, the nodes that are touching the line, are the ones that I send the path and I build the linked list based on that. And then the levels of each one determines how to show them. And then obviously the arrow is going to be the folder. And these already exists on the function there. Because it depends on the way you set the icons. So I can take from the one that I already have there. The only difference would be the way that you draw the levels. So I'm going to stop streaming now, and probably next time I'm going to go over this. So I think I'm going to go over with the debugger, and then I'm going to put breakpoints on the constructor and on the parts. I think that's the notification draw. So it's both create item. I think that this is the one that creates the linked list thing between the nodes. I think that's the way that they determine how they're gonna create the layout. And then it's gonna be on yeah, the problem is that it's two different classes, but I think it's on notification draw. So I think the main thing that I have to figure out is how do they, it's probably gonna be on this cells here. How do they determine this space between the levels? And how do they draw the line here? Once I understand that, then I have to translate that into the way that I want to do there. That's going to be based on the level from the model. But it might be very hard. But I think it's probably worth it to do this. I'm also going to learn about a lot. Like this stuff about the shape here is very interesting to me because it's a fundamental principle. And I think once I understand that very well, then like a bunch of other problems become very easy to think about. But that's why I'm very interested on spending a bunch of time thinking about this. I think it's worth it. So next time I'm probably gonna study the tree and tree item classes. And if I can't use the tree and tree item to do what I'm thinking about, then I'm just gonna copy the classes and then change whatever I have to change to make this path work. Then once I do that, I can think about these algorithms here, which is gonna be finding the data structure of the path and then loading the tree data structure based on the path, sending the information to the front end that is gonna build the queue that represents the path, and then using that to display the stuff with the virtual scrolling already. Yeah, so see you next time.